In this video, I will be discussing some basic concepts regarding work, energy and power. First, we shall see what work is. In physics, work is said to be done when a force moves an object by a distance. That is, work is said to be done when a force acts on an object and the object is displaced. Then only we can say that work is done. That is, in case if we are pushing a heavy stone and if the heavy stone is not displaced, then we can't say that work is done according to physics. But we know that energy is being expended by us while trying to push the stone. Now we can see the formula for work. That is, if a constant force F acts on an object and it is displaced through a distance s in the same direction as the force applied, then the total work done is given by work done is equal to the product of force and the displacement. Work has only magnitude and no direction. Work is a scalar quantity. Work done can be positive or negative depending on the directions of force and displacement. Force and displacement, as we have seen earlier, are vector quantities. And if the direction of force is opposite to that of the direction of displacement, work can be negative. The unit of work is joule or Newton meter. 1 joule is the work done by a force of 1 Newton to move an object by a distance of 1 meter. Now we can see what is energy. Energy is the capability to do work. That is, without energy, we can do any work. An object possesses energy if it can do work. The object doing work loses energy and the object on which the work is done gains energy. That is, for example, in the case of hammer hitting a nail, when the hammer hits on the nail, the energy is transferred, the kinetic energy of the hammer is transferred to the nail and hence the nail goes into the surface. The unit of energy is same as that of work, since it is the capability to do work. It is the same as that of work, which is joules. Now, there are different forms of energy. For example, kinetic energy and potential energy. These two forms of energy are discussed in detail in the upcoming slides. We can see what kinetic energy is. Kinetic energy is the energy possessed by the body by virtue of its motion. That means a body which is in motion possesses kinetic energy. If it is stationary, its kinetic energy is zero. Kinetic energy of a body moving with a certain velocity is equal to the work done on it to make it acquire that velocity. In this figure, we can see that a mango is falling towards the ground from a mango tree. Here when the mango falls, it is acquiring an acceleration due to gravity, that is g. And hence its velocity increases and its kinetic energy also increases. The kinetic energy of the mango is maximum when it reaches near the ground. When the mango reaches near the ground, its kinetic energy is maximum. That is when it has got maximum velocity. Now we can see the derivation for a basic formula of kinetic energy. By third equation of motion, we have got v square minus u square is equal to 2as, where v is the final velocity, u is the initial velocity, a is the acceleration, s is the total displacement. On rearranging, we get s is equal to v square minus u square, the whole divided by 2a. Now work done is given by the formula W is equal to force into displacement. Now by Newton's second law, we have got force is equal to mass into acceleration. That is, work done becomes mass into acceleration into v square minus u square by 2. On multiplying, we get work done is equal to m into v square minus u square by 2. If the initial velocity of the object is 0, then the work done becomes W is equal to half mv squared. Work done is given by change in kinetic energy. Hence, we can say that kinetic energy Ek is equal to half mv squared. This is the formula for finding the kinetic energy of a object moving with the velocity v and having a mass of m. Now we can see potential energy. Potential energy is the energy stored in the body or a system by virtue of its position in field of force or by its configuration. Examples include energy possessed by a stone kept at a height, or the energy possessed by the water being kept in a dam, or the energy possessed by the compressed spring. In case of the compressed spring, the potential energy is due to its change in configuration. While in the case of the dam and the raised stone, it is due to its position. Now we can see a body of mass m, which is raised to a height of h. Then the work done by a body of mass m to be lifted to a height of h is given by mgh. Here, mg is the force of gravity, that is gravitational force, and h is the total displacement. We know that work is the product of force and displacement, and hence we get the total work done to raise the body to a height of h is equal to mgh. Now the energy gained by the body is hence mgh. Hence the formula for potential energy due to gravitational force is given by the formula mgh. Now, law of conservation of energy. The law of conservation of energy is a very important concept in physics. It states that the energy cannot be created or destroyed, but only changed from one form into another or transferred from one object to another. We can see the case of the falling mango from the mango tree due to gravity. When the mango is fixed to the tree, it has got potential energy and zero kinetic energy. Since it is not moving, it does not possess any velocity. But when it starts falling, its velocity increases and hence its kinetic energy increases. Similarly, since the height above the ground decreases, its potential energy decreases. Thus, we can observe that the sum of kinetic energy and potential energy is a constant value. When the mango reaches just at the ground, the velocity is maximum and hence we have got maximum kinetic energy while zero potential energy. Now we can see what is the power. Power is actually the rate at which work is done. It is the amount of energy transferred per unit time. It can be given by the formula power is equal to work divided by time. It is also a scalar quantity, just like work. In the SI system, the unit of power is joule per second, which is called watt, in honor of James Watt, the 18th century developer of the steam engine. Its commercial unit is kilowatt hour, which is the energy used in 1 hour at a rate of 1000 joules per second, which is equal to 3.6 into 10 raised to 6 joules. Hence, this is the end of the video. In this video, we have discussed some of the basic concepts about work, energy, and power. Hope all of you have understood whatever is discussed in this video. If you have got any doubts, please comment in the section below this video.